Hello class 10. From today we are starting the chapter wise introduction, concepts and summary of all chapters. So without skipping, watch the video. Class 10 आज से हम लोग स्टार्ट कर रहे हैं चैप्टर वाइज इंट्रोडक्शन, कॉन्सेप्ट एंड समरी सभी चैप्टर्स की. तो बिना स्किप किए पूरा वीडियो आप देखिएगा. तो फर्स्ट चैप्टर इज रियल नंबर, इंट्रोडक्शन एंड कॉन्सेप्ट एंड समरी ऑफ रियल नंबर. तो पहला चैप्टर हमारा रियल नंबर है. रियल नंबर मीन्स ऑल टाइप्स ऑफ द नंबर that can be represented on number line. Broadly, we can say the mixture of the rational and irrational numbers. A real number includes all negatives, positives, square root, without square root. All types of the number are real number. Composite number, the numbers having the more than two factors. For example, 15. Factors are 1, 3, 5. More than two factors. So it is composite. And for example 17 is not a composite because it is having only one and itself, so it is not a composite number. Only two factors. More than two factors means composite. Prime number having only two factors, we can say the 17 is prime number because one and itself, or simply we can say which do not fall in any table. किसी भी टेबल में नहीं आता है, अपनी ही टेबल में आता है 17. So it is prime number. 13 is prime number. Smallest prime number is 2. 15 is a not prime number because it is having more than two factors. So very simple. More than two factors means composite, and only two limited factors prime number. Co-prime numbers mean pair of numbers or more than two numbers having only one common factor. Like 17 and 12. The common factor is 1. 13 and 15 having common factor 1. You do not be confused. Co-prime means that should be the prime. Not necessary to having the prime numbers. Any numbers, any pair of numbers having more than two numbers having one common factor. So these are co-prime numbers. Prime factorization is a very easy term. Right from lower classes you have been seen. But here the prime factorization question are very deep. See, let us take up one example. 8, 2, 3, 2. And you try to do the practice tree method. This is called the tree method. If I divide by 2, you have to start with the prime number, lowest number 2 or 3. Because the number can be even or odd, so you start with the 2 or 3. So 2, we are dividing. Again we are dividing by 2. Continuously we will factorize till we get the prime numbers. Now this is an odd number. So let us try with 3. 3 3 is 9. 3 4 is 12. And 3 3 is 9. Now 7. Again 7, 1, 2, 3. There are 3 2's, 2 की power 3. 3 is only 1 and there are 3 7's. So 7 to the power 3. This is a complete factorization. Prime factorization, in fact we can say this is a prime factorization. Now listen student, the question may be asked like this. I have written here, find the value of n in this prime factorization. This question may be asked MCQ, accession based questions. So for this you have to do the factorization. So see the factorization here, 7 to the power 3. So means here our answer will be n3. And question may be asked like this, in a tree factorization, in a tree method, one box may be here and the question mark. Complete this box. So it may be the one more box empty. Complete this box. So do the deep practice of this prime factorization of bigger numbers. Now HCF and LCM. I think these are also familiar words for you. But here you have to do the deep study. See the statement, the very important statement. So HCF is a product of common prime factors with smallest power. LCM is a product of each prime factors with greatest power. Let us have one example. 120, 108, two number. Let us first write the prime factorization. So in order to prevent the time, so I already done this factorization by tree method. See, these are the factors, prime factors. Now HCF, product of common prime factors, common. What are the common here? 2 and 3. 2 and 3. With smallest power. Listen, with smallest power. 2 smallest power is 2 to the power 2. And 3 smallest power is 1. Without power means 1. So HCF is 12. Now come to the LCM, product of each prime factor. Listen here, product of each prime factors means all factors you have to write whether it is a common or not. 2, 3 and 5. 2, 3 and 5. Now, with greatest power. So listen the difference with greatest power. Greatest power 2 to the power 3. 3 greatest power is 3 and 5 is only 1. So if we multiply 8, 27 into 5, 8 5 is 40, it is coming 1080. So this is the LCM. This is HCF and this is LCM. So in this way you have to perform the HCF and LCM in class 10th. Now see the very important relation in between HCF, LCM and the numbers. HCF, just now we found it is 12. LCM, it was 1080. Product of numbers means 120 and 108. It is coming 12,960. This is also coming 12,960. So it is verified that the HCF, product of the HCF LCM is equal to the product of the numbers. Question may be like this: if HCF of two numbers is 12 and the numbers are 108 and 120, and find the LCM. So in this way you can ask, or it can be asked, if the one number is given 108, 108, find the other number. So by using this relation, you can solve this kind of the questions. Fundamental theorem of arithmetic. So very easy regarding the prime factorization, a general statement. In short, I am writing in a very easy language. Composite number can be factorized in a prime factors. The prime factorization of composite number can be done, but the prime factorization is in unique way. This word you have to use here. What is the meaning of unique way here? What is the significance? Listen. For example, we are doing factors 2 into 2 into 2. So this is a unique. We cannot change. We cannot insert any number. For example, 15. So 3 into 5. 20. 2 into 2 into 5, like this. This factorization is unique, means we cannot insert any other number. We cannot change. We can change the order 5 into 3 or 3 into 5, but we cannot insert any other number. So in this fundamental theorem, regarding this theorem, the question may be asked like this: check which number can be AND with the 0. Among these three numbers, this 20 can be AND with 0. Why? Because it's having a 5 and 2. So this 5 and 2 means it is a uniqueness. Because of this, this can be AND with the 0. When you will see the question, you will understand better. But these number cannot be AND with the 0. And we cannot do anything for, we cannot insert any number to AND with the 0. So these number cannot be AND with the 0 because not having the combination of this 5 and 2. Now theorem 1.2, the very simple theorem, very useful theorem. P square divide by A, then P can also divide by A. Like this, 100 can be divided by 2, very simple, 50. Or we can say 100 means 10 square can be divided by 2, So without square, a square of number can divide by 2, any number. Then without square can also divide by. Another example, 25 can divide by 5. Or we can say the 5 square can be divided by 5. So without square, 5 can also divide by 5. The very simple theorem and very useful theorem. Now student, next concept is the proof of irrationality. This kind of the question you will find in this chapter. Prove that root 5 is irrational number. First of all, we will start letting the root 5 is rational. Let us suppose that root 5 is a rational number. We use here the contradiction method. Rational number means we can represent by a upon b, and we'll mention here b is not equal to 0 and a and b are co-prime numbers. Now cross multiply, a is equal to b root 5 and squaring both sides. A square is equal to 5b square. Now listen student, this implies that a square upon 5 is equal to b square. In other way, we can write a square divided by 5 is equal to b square. See, recall that theorem we just now did. Any square of any number divided by number, then without square is also divided by same number. So we can mention here, we know that p square divided by a, then p can also divide by a. This is a simple theorem representation. What does it mean? A can divide by 5. So we can suppose that put a is equal to now 5 times of any number. Since it can divide by 5, so we can assume again the a is equal to 5c, where c is positive integer. Suppose this equation is 1. So put the value of a in first equation. From 1, 5c square divided by 5 is equal to b square. 25c square divided by 5 is equal to b square. Now see student, b square divided by 5. This implies that without square can also divide by 5. Now from equation number this 2 and 3, what conclusion we are getting? Listen, this is an important term. A divided by 5, b divided by 5. This implies that a and b are not co-prime. So it shows that a and b are not co-prime. So this is the contradiction. Contradiction means we suppose that rational, now we prove it wrong. So it means root 5 is irrational. So we'll write here, it contradicts our assumption that a and b are co-prime. Our assumption is wrong. Our assumption was root 5 is rational. But we prove here our assumption is wrong. It means root 5 is irrational. Hence prove. Now see student, in the proof of irrationality, the another kind of question is 3 plus root 5 is irrational. This is very easy. Again, we will start with the same procedure. Let 3 plus root 5 is rational. So let us suppose a upon b is 3 plus root 5, where a and b are co-prime integers. Now in this kind of the question, we will rearrange, we will shift 3 here is equal to root 5 a minus 3 b upon b is equal to root 5. Now focus here student. In LHS, a, b, 3 are integers. In LHS, all numbers are integers. So this whole expression is rational. In LHS, whole expression is rational. But in RHS, since 5 is not a perfect square means 25, 100 and a root can be rational. But it is not a perfect square, so it is irrational. So it contradicts our assumption that LHS equal to RHS, but in LHS rational, RHS irrational. Again contradiction here. So we will write here, this contradiction arises due to our wrong assumption. This contradiction, LHS, RHS are equal, but they are not in the same nature because of our wrong assumption. What was the wrong assumption? Wrong assumption was 3 plus root 5 is rational. So what is true? Hence 3 plus root 5 is irrational. So my dear student, this was just exploration and introduction of chapter 1 real number. You do the practice, and the NCERT solution I have already uploaded on channel. Thank you.